Welcome back, and we're today going to deal with section 6.5. We're going to do day 1 today of 3, and our focus today is on solving polynomial equations. This is an extension from 6.4. 6.4 you did a ton of factoring, and now we're going to take that one step further. So our first step is being able to find the zeros in a polynomial equation. So our first step that we're going to do is we're going to set that equation to 0. I've already done that for you in this first problem. Step 2 is then going to be to factor that polynomial. So when I look at this first one of x cubed plus 2x squared minus 48x, I see that we have a GCF of x. So I'm going to start by factoring out that x, and I'm left with x squared plus 2x minus 48, still equal to 0. Then I want to take this next part of x squared plus 2x minus 48, and I am going to go the route of finding something that multiplies to negative 48 and adds to 2. So the first thing I think of, because 2 is positive, so the bigger number has to be positive, I've got negative 6 times 8. Negative 6 plus 8 gives you positive 2. So I know that I have here my x still out front, and now I've got x minus 6 and x plus 8, still equal to 0. Now if you remember, we've got the zero product property, which says that if we have 2 or more factors that multiply to get 0, one of them must be equal to 0. So that means that in our case, either x equals 0, x minus 6 equals 0, or x plus 8 equals 0. So when we solve them, obviously x equals 0. Adding 6 to both sides, we get x equals 6, and we get x equals negative 8. That means that my zeros are x equals 0, 6, and negative 8, which if we wanted you to write those as ordered pairs, that would be 0, 0, 6, 0, and negative 8, 0. And in 2 days on 6.5 day 3, you'll need to know that so we can then use those in our graphs. So then step 4 is going to be that these are your x-intercepts if they are real zeros. Remember, complex zeros aren't x-intercepts. And we're not going to get too in-depth with that. Just know that if you happen to get any complex zeros, for today, we want those zeros, but know that they aren't going to intercept the x-axis. Moving on to our next example, we have here that x cubed equals 49x. So the first thing I want to do is subtract my 49x to get them both on the same side. So now we've got x cubed minus 49x equals 0. I then see that I have x's in common, so I'm going to factor out that x, giving me x squared minus 49. I see that x squared minus 49 is a difference of squares because the square root of x squared is x and the square root of 49 is 7. That means that I have x times x plus 7 times x minus 7. And therefore, now if I set this equal to 0 and solve, I know that x equals 0, 7, and negative 7. And for the purposes of today, this will suffice for your answer. Moving on to part C. We have b of x equals x cubed minus 4x squared minus 3x plus 12. I see 4 terms. I know that 4 terms means I can factor by grouping. And I'm going to turn this into plus a negative 3x, so I remember that there's a plus sign out front. In my first term, x cubed minus 4x squared, there's an x squared in common. That leaves me with x minus 4. And then I see on the other side, I can factor out a negative 3, which leaves me with x minus 4. The ones that we have in common are our x minus 4. So therefore, I have x minus 4, and then I have x squared minus 3. So when I set this equal to 0, because this should have been 0 to begin with, I have that x minus 4 equals 0, and x squared minus 3 equals 0. So when I go to look at this, x minus 4 equals 0 means that x equals 4. And here, I bring the 3 to the other side, giving me x squared equals 3. I square root, which means that besides x equaling 4, that means x equals plus or minus the square root of 3. Please make sure you have that plus or minus in there.